This is the Algebra 2 Final Review Part 2. We are going to start with number 9 in reviewing. So let's look at that question here. We have 1/9 equals 27 to the 7x minus 6. Remember or keep in mind that x is an exponent, so we have to get rid of the bases. And to do that, first we are going to change the fraction, which is the 1/9. We're going to take the denominator and we are going to use a -1, and that's the same thing as a fraction of 1/9. The other side is going to stay the same. And now we're going to have to get rid of the bases. Now to get rid of the bases, they have to be the same number. So we are going to change the 9 with the base of 3. And if you use 3 squared, that's going to equal 9. And you bring down the -1. 27, you can also use base of 3, but we have exponent of 3. 3 cubed is 27. And you bring down the exponent, 7x minus 6. When the bases are equal, you can cancel the bases. You're going to multiply the exponents. Remember, you have to distribute the 3 to the 7x and the 6. So we have, you multiply minus 18. And this is an x. Let me make that an x again. There we go. So now we just solve for x. So you get rid of the 18. So we got 16 equals 21x. And finally, so now we divide by 21. And finally, the answer is right here. Make sure that if you have a fraction, you always try to reduce. You want to simplify. 16 over 21 cannot be simplified, so the answer is C. All right, so I'm going to move on to number 10. I'll do that for you guys too. And it's the same one as number 9, but we don't have a fraction. But I can do it, so let's go ahead and do number 10. And number 10, they have different bases. The exponent has the x. So first, let's go ahead and change the 8. We can use base of 2. And 32, we can also use base of 2. So let's go ahead and change the 8 to a 2 cube. That equals 8. And make sure that you keep the exponent that you have outside of the parentheses. And on the other side, with the 8, we have 2 to the 5th power. That equals 32. And we have the x outside. So now we can cancel the bases. They're the same. And you are going to multiply. You're going to distribute, multiply here. So the big idea is just to get rid of the bases. We have 24. Solve for x. So we subtract 3x from both sides. Divide by 2. And we got 12. Cancels. So answer is A. And number 11 is a little bit different. If you look at the answers first, notice that they all have logarithms. So they didn't evaluate, they didn't use the calculator to find the decimal number or the answer, the actual answer. But we have to simplify. So once again, the x is an exponent. Now here, 3, the base of 3 and 60 cannot change, cannot have the same base because 3 is already a prime number. But we can use logarithms. This right here is an exponential form. X is an exponent, so we can change it to logarithms. So to change it to logs, you just write down the word log. The base is 3, so you put base of 3. You go to the other side, 60, and then you come back to your exponent, 2x. Remember that we do that little cycle when we convert into logarithms. So from the base, the other side, and then you come back. Now, here, we do have to get x by itself. But first, if you look at the answers, let me erase this here. All the answers, they have logarithms. So what I can see is they used the change of base formula for the logarithm. So on the left side, the change of base, you take log of the result divided by log of the base equals 2x. Then we have to divide by 2 to get x by itself. And since we already have a fraction on the left side, I don't want to make another fraction. So all we have to do, the 2 that you're dividing by, it's on the bottom. So we're going to put the 2 on the bottom of the fraction right there. So we have x equals all of this. So the answer is B. And let's go ahead and do one more. Let's look at number 14. So we have ln. We have to remember what's ln. And ln, it is a logarithm, but the base, so ln is going to become the logarithm with the base of e, natural base e. That is another way to write ln. If we keep what we have already, which is the e, and we have the negative 5x power, when you have logarithms with the same base, so this base are equal, you can cancel. So once you cancel, you just keep the exponent. And the exponent is negative 5x. So the answer is D.